Hey, manufacturing world. Welcome to another episode of Shop Matters, sponsored by Okuma America. I'm your host, Wade Anderson, and today I'm joined in the studio by John Wiley with QualiChem. Today we're going to talk about all the things coolant-related, which I think is one of the most overlooked parts of the actual chip-making process. So, John, welcome to the show. I appreciate you coming down.
Thank you, Wade. Appreciate being here.
Tell us a little bit about yourself.
So I've been with QualiChem now for 10 years. This is the third metalworking fluid manufacturer I've worked for. Started at IMTS in 1992, so almost 30 years in the business. Always really metalworking fluids, so I have a pretty diverse background in that.
Okay.
And,
Very good.
Yeah.
So I guess tell me a little bit about how you go to market. Tell us a little bit about QualiChem in general.
Yeah, so the guys that started QualiChem about 15 years ago, they all came from different, bigger manufacturers. And one of the things that they believe strongly in is that this is a people business, very relationship driven. We use that then, and we go to market via distribution. We have very talented sales engineers in the field who understand the applications, what can go right, what can go wrong, how to help the customers get the most of the product, and we support the distributors then in the selling process. The distributors provide the local inventory, the local relationships, and that's been the model we've used for success now for the last 15 years.
Okay. Now, you mentioned IMTS. You guys are, I'm sure, just like us, wide open, full steam ahead, getting ready for IMTS. Do you have anything new that you're going to be rolling out for the show?
Yeah, so this year we're gonna take a little bit different approach than we had in the past. We haven't really highlighted our technical capabilities and our lab capabilities as much in the past as we'd like to now, because we're realizing more and more that's one of the differentiators for ourselves. So we're going to make that part of the booth experience, in addition to, of course, the actual user end experience of the product. And then we've been exploring a couple new base oil technologies that, we started it in the straight oil product line first, where like Swiss style machines and whatnot would be using. But we've managed now to incorporate those base oils into the types of fluids you'd see being used in an Okuma. So we're going to highlight those. They bring to the table some interesting benefits with respect to cleanliness, longevity. They're base oils that are derived from natural gas. One of the big refining companies figured out how to convert natural gas into a liquid oil. So you get a lot of benefits of some of the more highly refined base stocks that are crude oil derived.
Okay.
Without all the refining time and processing, because natural gas is naturally very clean. So a lot of what you would take out of crude oil doesn't exist in natural gas. So the benefit is you get a lot of the characteristic benefits without the price of a highly refined product. And we were the first ones in the U.S. to start employing this base oil technology. So we have a head start on everyone else, and we've got a pretty broad range of products. It's actually one of the products we'd like to introduce to you guys over at the Think Center.
Okay, excellent. So you brought up Think. Obviously, that's a big part of my world, the Partners in Think program with Okuma. Tell us a little bit about your view and your partnership and how you see that program working for QualiChem.
Yeah, so we've been involved with Partners in Think since about 2012, thereabouts, maybe 2011. I'm a big believer in the participation with Okuma. It was, again, about almost 10 years ago that we were invited down. I think it was Rick Kimmons who was involved with that. We were able to demonstrate to Okuma and one of your other partners at the time our capabilities with controlling foam. It was very early on one of the characteristics that we really differentiated ourselves from the competition. Back in 2008, 2009, when a lot of things had slowed down in the marketplace, a lot of our competitors weren't innovating. They were just kind of taking a defensive position. We were very new at the time. We have a really excellent formulator who focused on, what is the competition not doing? And nobody was really addressing the root causes for foam. So we put a couple products together. I should say he did. I joined the company a little bit later. But our ability to show you guys what we could do with foam control led to the invitation to be a part of Partners in Think. And as you mentioned in your intro, coolant's often a very overlooked component in the shop and the manufacturing process. So we try to offer ourselves, as you guys know, we're always available to assist the application engineers in projects. If there's I think it was Matt we worked with recently, he had a project that he was looking for specific characteristics, so we sent in a product specific to that project. We also take the approach, most of your application engineers have a favorite QualiChem product that they, it's sort of a go-to. It's sort of a jack of all trades. It's good for aluminum, good for titanium, can be used for cast iron, carbon steels, etc. But of course, when the opportunity presents itself, we enjoy the opportunity to kind of put a best case scenario in products that are specialized from a cost perspective, but also a benefit perspective for the user, such as products that are specialized for titanium or products that are specialized for aerospace aluminums or the oil and gas industry. I was on a call yesterday with some Okuma people down in Houston. We're looking to put together a demo for a couple guys down there. And the oil and gas industry is very different than the aerospace industry. And
Right.
So we've got a broad range of products that can be very specific to the applications or very job shop oriented, do a little bit of everything.
Right. Okay. So I get called to go to customers every once in a while. A lot of times it's problem related. Customers got an issue in the field. It's went to a certain level. I get a phone call to go down and take a look at things and either try to sort it out or find the right people that can sort it out.
Yep.
And coolant and filtration. I'm going to do a separate podcast later with a company regarding solely the filtration side of things. But coolant is something that most customers, I can't say all of them, there's some that are really tuned in, but a lot of customers, it's just whatever they've got in their shop. So if they're running aluminum or they're running titanium, they're pulling coolant out of whatever drum they already had sitting in the shop. They bring it over, put it in the machine. And then, like aluminum, for an example, the fines. I know there's different types of coolants that'll allow fines to basically flow through the coolant,
Yep.
get to the bottom of the tank. Other ones tend to aerate. And a lot of times the fines, when they're floating, it's usually an aeration problem with the coolant itself. So what do you see in the field when you're going out and say, let's look at an aluminum application, for
Sure.
example. What would you do? What would those steps look like? And then what products would you try to recommend?
We usually need to step back and take a look at how the customer does things from a sort of 30,000-foot view. As you mentioned, a lot of shops will just use what they have, or they're buying from somebody local that they trust and know, and don't really evaluate the product characteristics per se. So if a customer has a machine and a filtration system and a material mix, we have to provide something that's going to work with all of that.
Mm-hmm.
Usually the capital investment stuff gets selected first, and then we've got to put something in that's going to work with it. So depending on how the filtration system's set up, sometimes you want the fines to be carried with the coolant so it gets to the filtration system. In certain applications, you want the fines to drop out because you want them to the conveyor, and the conveyor processes them.
Mm-hmm.
So, each application's a little bit different. We're working on a project right now with some companies up in the Bay Area that, they need 2-micron filtration capability. They're using some really small diameter drills. It's, for semiconductor components. And one of the things that we've been able to demonstrate to these companies is our ability to, the particle size of the metalworking fluid, for example. It's not something that gets discussed very often. But for the most part, with our Extreme Cut 250, I think you guys are using the 251 in the Think Center.
We are. Yep.
The 251, for example, the average particle size is around 0.16 microns. So when you're filtering it at 2 microns, you know that the fluid itself is going to be passing through. The filters get to do what they're supposed to do. You're not clogging the drills up with, particles that in some cases you can barely even see because the holes in some of those drills are ridiculously small. So that allows the filtration to work the way it's supposed to, allows your high pressure system to push the coolant through the drills the way it's designed to. So it's really, like I said, we don't usually get to select the best case scenario. We have to work with the conditions that exist. I often point out to guys in the shops that there's very few things that touch everything in the manufacturing process the way a coolant can. The purchasing guy gets involved, the production people get involved, programmers get involved, maintenance guys get involved. HR gets involved because the operators need to be happy with the coolant. Is it affecting their skin? Do they like the way it smells? Environmental guys get involved, safety guys get involved. You don't really see that with, cutting tools or machines or anything else really that a shop will buy. So in addition to trying to select something for the manufacturing processes, which is what we enjoy doing, helping customers get the most out of their process, but then you got to factor all those other things into the equation. So it's, I would say in maybe 20% of the scenarios are we actually getting to recommend a product solely based on what we can deliver from a productivity perspective and providing a benefit.
Right.
Sometimes it's, I can't have this chemical, I can't have that chemical, so what are my options?
Right.
And then you go in with sort of, okay, well, with those restrictions, here's what we have.
Okay. So, John, you mentioned earlier about foaming and how the products you developed are superior from a foam control standpoint. If I'm a manufacturer and I'm running a LB3000 lathe, for an example, if I'm witnessing foaming issues, what steps do I look for? What do you guys do as a company to come in and help solve those problems?
Sure. Well, from a troubleshooting perspective, I mean, the number one thing anytime you're using a water dilutable coolant is making sure that you're running at the proper concentration. Because a lot of shops struggle with managing concentration effectively and consistently enough where you can't overlook that that's probably, let's say 6 times out of 10 the cause. The concentration's either allowed to go up too high, or in some cases too low actually can cause you issues because you're not getting enough of what will control the foam into the coolant itself. So, after ruling out concentration as a cause of foaming or a contributor, looking at water quality is the next step. Understanding, is the customer using city water? Are they using treated water? Why are they using treated water? Because water with mineral content here in the Carolinas, the water tends to be soft to medium hardness, and most shops don't need to treat the water. So you get some natural defoaming characteristics from the water itself. You travel a lot. You've probably seen when you've been in hotels and regions where the water's so terrible they got to soften it before you shower.
Yeah.
And it feels like it takes forever to get the soap off
You
your
walk
body.
out, yeah, it feels like you've drowned yourself in bleach trying to get out. Yeah.
So that, in markets where, like Arizona, for example, probably 90% of the shops need to treat their water before they use it. Those shops have a higher tendency towards experiencing foam because the minerals that would otherwise help prevent foam aren't there. So again, knowing that, you build your product around, at least we do, the understanding that, okay, there's some components we can't rely on not coming from the water now. So how do you build your product? So one of the things that, as I mentioned earlier, back in, the early 2000s when they started formulating a QualiChem, the traditional approach with controlling foam was put in defoamer into the concentrate. The defoamer floats to the surface, the bubbles pop, you don't have foam. Problem is, as high pressure became more prevalent, and high pressure usually incorporates filtration, defoamers can be filtered out. So that's another part of the troubleshooting process, is understanding, are there accessories that will
What kind of
contribute
filtration units are they using?
Exactly.
Okay.
Usually the guys that develop the systems will say, okay, you go with the lowest micron size you can on the filter. That's not often always necessary, so trying to work with either the filter guy or the high pressure guy and understanding really what's necessary, because defoamers can be filtered out. But one of the things that we do is we work diligently on, when we formulate, not using the chemistries that are more prone to foaming in the first place.
Okay.
So there's a lower reliance, or sometimes no reliance, on defoamers themselves, which allows us, as we've done globally, to comfortably walk into shops that are running deionized or reverse osmosis water that's purified. The mineral content is gone, so those natural defoamers are gone. We easily work with companies that that have treated water, and we're not afraid of 1,000 psi, 1,500 psi. Once you start going above those, then you sort of have to evaluate the technology you bring to the table, and we have a variety of products that are suitable for 2,000 plus.
So that was a question I had. You kind of led right into it, but we're seeing pressures on demands from customers on pressures for through spindle coolant, things of that nature, driving up at a very rapid rate.
Yeah.
For a long time, high pressure was considered 1,000 psi. Standard might be 100 to 300,
Yeah.
and then you kind of make that jump up to 1,000. Now it's commonplace for the high nickel alloys to see 2,000, 3,000 psi. Does that change your focus from a coolant technology standpoint, what you would recommend on the machines?
Yeah, without a doubt. I mean, 2,000 plus, you really start to test the ability of a product, not just to not foam, but to not just split apart. And high speed face mills present the same challenge.
Define that a little more. Split apart.
Well,
what does that mean? If I'm a
most of the coolants on the market there's an oil, there are emulsifiers. You create a situation where the metalworking, the coolant is suspended oil droplets and other additives, not separating naturally from the water.
Mm-hmm.
But there are forces such as really high speed face milling, for example, or in some cases pump design that can challenge the chemistries that keep the coolant together.
Okay.
So as you get into scenarios where you are 2,000 plus psi, you have to go in with the right product technology that it's going to stay together, two, it's not going to foam, and three, is actually going to bring to the table a benefit that it's worth having in the machine in the first place.
Right.
2,000 psi, if you were to just put straight water in the machine, you're likely to have foaming. Now, not foaming the same way you would have if you were to pour some soap into the tank then.
Right.
But, it's 2,000 psi, 3,000 psi is a challenge.
Okay. No, that's interesting.
Yep.
To back up a little bit, you mentioned the concentration levels and making sure that the concentration is correct. How much, I guess, one, is there, how do customers know what they should be running? And then two, how many people are you seeing adopt automatic technology that automatically adjusts and feeds to the machine tools? I know we've got offerings from an Okuma standpoint.
Yep.
I know there's third-party companies that have offerings as well. Are you seeing that implemented much in the field?
Well, in the almost 30 years I've been in the industry, we've seen that trend. It'll surface, and then there are some challenges that kind of put it back down to where guys are just going to do it manually. More and more as shops are trying to reduce their dependency on labor to do things and to automate, because we're in an industry where the more you can do in an automated way, the more consistent your output. Some of the long-standing challenges with automated concentration control is allowing see what you typically do is you put light through the coolant and you measure the amount of the refraction, the amount the light bends as it goes through the fluid. That's usually translated into a concentration. There's usually a conversion to do that. The ability to keep that lens or objective clean has historically been the challenge. And the companies that can do that generally have an easier time with an automated process. As far as how a customer knows what concentration to run, ourselves and most coolant manufacturers will design a coolant with sort of, here's the minimum concentration where you're not going to have rust and corrosion and problems. Here's the maximum concentration where you're not going to suffer from skin irritation, paint coming off the machine, foaming, et cetera, and just general waste. For the sake of our discussion, let's say most coolants are designed to operate from a 5% volume in water to up like 12%. Depending on the customer's objective, their style with manufacturing, if they're really looking to push things and get the most out of their tooling, generally we tend to try to steer the customers towards the higher end of that spectrum. Normally, the more lubricity, the more additives you're delivering into the point of cut, the more your tools are going to last, the better surface finishes you're going to have, the more ability you're going to have to carry the fines out of the cutting zone. If you're running down closer to the minimum concentration. It doesn't take much for an operator. Maybe he overfills the tank, too much water. Now you're at 3%. Now you don't have enough corrosion control for your, carbon steels, your cast iron.
Right.
So I would say the vast majority of our customers are running somewhere like 7 to 8% concentration. The other important discussion with respect to concentration is understanding what the fluid you're using actually. When you use a refractometer or an automated system, what are you actually looking at? Because a refractometer will measure, not in a very technical term, stuff in water. So a lot of our products, like the 251 that you guys use at the Think Center,
Right.
is what we would call a direct read. So if a guy's using a refractometer and the refractometer shows 7 bricks, because that's the scale that refractometers use, you're at 7% by volume. Some coolants will have what's called a refractometer conversion or refractometer index, where if your refractometer says 7, there's a multiplier, maybe it's 1.5 or something. So your actual volume of concentrate somewhere around 10% or 11%. And the reason for that conversion is because some of the concentrates, the stuff you're diluting with water, already has water in it.
Okay.
So you're compensating for that in the measurement. So it's good, to work with a reputable coolant manufacturer that helps you understand, because sometimes their customers are led to believe, well, you're running at 3% because that's what the refractometer says. And then they ignore the fact that there's 3 conversion factors. So you're actually 9% by volume.
Right.
So sometimes it's harder for customers to make a good judgment about, well, I've got this other vendor here saying I got to use their stuff at 8%, but I'm using mine today at 3. Well, you're not really using it at 3. You're at 9%. So you're
Right. It's a calculation.
It's a calculation, and so understanding that's part of what a good coolant manufacturer will help the customers understand. But yeah, maintaining. I've always told customers maintaining concentration properly is about 70 to 75% of the work of the coolant maintenance program. The next step after that is let's deal with the contaminants. The tramp oils that might get in there. That's another 15-20% of the process. And then in surface finish intensive applications, you want to get the fines out.
Right.
Whether it's grinding or reaming or, any type of work. And now more and more with high pressure and the filtration demands there, it's a bigger component. But if you have good concentration control, the vast majority of coolant issues that companies have wouldn't exist.
Okay. That's interesting. So from a John perspective, what's the top 3 things you want customers to know and remember about QualiChem?
Well, we're a technology-based company. We focus on not just making coolants that won't cause problems, because we have those, but we really like to work with companies where we can show them a productivity advantage. That's one of the reasons we like working with Okuma, because it's about helping the customer advance their process. We're a people and relationship-driven company. We have resources available to help the customers that need it. Whether it's from a troubleshooting perspective or an optimization perspective. And we are, we're a global company, so we're aware of all the regulations globally. We're formulating from the perspective of, we're always keeping our eye on what regulations might impact manufacturing next from a metalworking fluid perspective. So the customers that are working with us know that, whatever changes might be around the corner, we're already formulating and understanding how that might impact our customers wherever they might be located.
Okay, excellent. How do they find you?
Well, we have a website. That's, the way I would say, maybe 20% of our new customers find us. But because we do sell through distribution, the vast majority of new customers we put on come through the relationships we're managing with the distributors.
Okay.
We are looking to expand our presence on the internet and allow some of those shops that might not have the resources or the time to deal with distribution to still find us. So we're doing stuff now on YouTube. We're working on this podcast with you guys. But I would say for the most part, most new customers find us through our relationships with distribution.
Okay, fantastic. So John, here lately, I've been super focused understanding return on investment and value for customers. How do we make them more productive? How do we look at their overall process and find, where do we get a greater return on their investment? And I find the efficiency tends to be what moves the needle the most from a bank account standpoint. From a return on investment to customers from a coolant perspective, what are you seeing?
Kind of along those lines, you keep the machine running, you're making money. So when it comes to coolants, keeping the machine running means, not having foaming problems that shut you down, not having sumps that need to be changed out every 2, 3, 4, 5, 6 months because they're rancid. So using a good product the right way and, training customers is part of what we do. Keep that coolant in the machine for 12, 18, 24 months. So you're not spending time on maintenance and, preventive maintenance type operations. Your operators are spending time at the spindle making parts. So just getting more out of a product that lasts longer. That's one of the things that we talk to the customers about. And then in, the certain scenarios where customers do pay attention to tool life and productivity and cycle time, and they allow us to recommend the best product for their application, getting the tools lasting longer, so there's fewer change outs or however the machine might be set up. But getting more out of the machine that you've invested money in, keep it running 10% longer per month because you're not dealing with change outs on the tooling or dealing with clamps or vices that you can't change because they're rusted to the table. I would say more often than not, we're justifying our existence by helping customers reduce costs associated with keeping the coolant in good condition. And then there's a smaller percentage of times when we're really given that opportunity to help customers improve their productivity and keep the machines running, the spindle turning longer.
All right. Well, thanks again for joining us for another episode of Shop Matters. John, I really want to thank you for your time today. I learned a lot about coolant and really understanding the value that QualiChem brings to the table for customers and how they could be more productive for the long haul and look at coolant in a different light.
Well, I appreciate being here, Wade, and it was a pleasure.
All right. So if you have questions, comments, please reach out to us at okuma.com/shopmatters. Until next time, thanks.